In this video, we will talk about ranking window functions. But first, we will create our sample table. We will create a table with one column of chart data type and another of integer data type. And we will place some data inside of our column. And then at the end, we can take a look at our table. So this is here our table. And now I will jump here to this web page. First, I will talk about this image here. So in the spreadsheet programs, we have these row numbers. Before column A, we have row numbers for each row, and we can create such row numbers in Monet by using row number window function. Similar to that function are rank and dense rank functions. Now, let's assume that on Olympic Games, there are two players sharing the same medal. For example, we have two players that won gold medal. In that case, the next best player will get bronze medal, and there will be no one with a silver medal. So we can see that here, first place, and then the third place. So we have a gap. This is so-called Olympic ranking, and in Monet database, we can achieve that with rank function. Beside that, we also have dense rank function. In this case, we don't have gaps. For example, let's assume that we are ranking apples. We will not apply Olympic ranking on apples. Instead of that, we will have consecutive ranks. So we will have first class, and then the second class, and then the third class. So there will be no skipping, no gaps. Now, these functions are only available as window functions, so they cannot work as regular SQL functions. But although they are window functions, we are not able to use frames with these functions because these functions will return a value for each row. And if we had several frames, for example, here we have 3 frames, we would get 3 values for this row. So what value to use? So frames are not applicable here. Instead of that, we will apply rank function on the whole partition. I will now give you an example for all the 3 functions. So we will run this statement here, and we will get a table with row number column. So we have numbers from 1 to 8. We have rank. Here we have gap. So we have a first place and then the third place. And we have dense rank. In this case, we have all of the ranks. So we have first, second, third place, and so on. Now we can notice several things. First, nulls. Here and here will get the rank 1. So that means that these functions are considering nulls the same. So this null is equal to this null. Second, for these functions to work, we need to have order by. And the third is that these functions are not using any arguments. We only have empty parentheses. Now, what if we omit order by? What will happen then? I will run another statement that is the same as this previous one, but without order by. I will run it. And for rank function and dense rank, we will only get number 1. So these functions are not working without order by. Row number is still working, but the order is unpredictable, order of numbers. But this row number column could still be valuable. For example, if we have duplicate rows, we have rows that are indistinguishable, then we can add row number column, and then we will have a difference between different rows. Now, row number function can be great for paging. Let's assume that we want to show data to our user page by page. And let's say that each page has only 3 rows. So we can create something like this. We will add row number column, and then we will filter only rows 1, 2, and 3. So if we run this, we will only get first 3 rows. And then after that, if we want to show to the user next 3 rows, then we can execute something like this. We are just changing the filter. Now we have rows 4, 5, and 6. So if we run this, we would get the next page. So this is how we can show data to the user page by page. Now, if we apply partitioning, in that case, nothing will change significantly. We will just restart counting. That is, we're going 1, 2, 3, 4, 6, and so on. But when new partition starts, we will again start from the 1. So that is the only consequence of partitioning. I will now clear my screen. I will now talk about the relative ranking. When we have a relative ranking, we are not expressing ranks as discrete numbers. So we don't have first place, second place, third place. Instead of that, our ranks are expressed as numbers from 0 to 1. I will now jump here to this web page and we will take a look at two relative rank functions. Those are cumulative distribution and percent rank. Now let's assume that we have 6 screws and we want to calculate what share of these screws is equal to 9 centimeters or less. We have 4 screws that match that condition, so 4 divided with 6 is equal to 66. And this is how cumulative distribution function works. So it is calculating an accumulation of probabilities. Let's look at this table here. A probability of each of these numbers is 1/6. And if we accumulate values until this row, for example 1/6 plus 1/6 plus 1/6 plus 1/6, we would get 4/6. So this is why this function is called cumulative distribution. I will now copy this statement here and I will execute it inside of the terminal so we can see how this function will work on our sample table. And this is our result, and here we can see numbers from 0 to 1. For example, this value here, 0.375, is calculated in this way. We are dividing 3 with 8 because we have 3 rows that are equal or smaller than 5, and in total we have 8 rows. I will now go back and I will clear my screen. Next, the relative rank function is percent rank. I will run this statement here to calculate percent rank. Inside of this column we have percent rank, and inside of this column we have rank. Now rank is used to calculate percent rank. I will jump to this web page, and here we can see formula that will help us to understand how percent rank is calculated. So the formula is rank minus 1 divided with total number of rows minus 1. For example, here in this third row, we have rank 3. So 3 minus 1 is equal to 2, and in total we have 8 rows. So 8 minus 1 is equal to 7. So 2 divided with 7 will give us this result 0.28. I will now clear my screen. Next, we will talk about entile function. Entile function is used to divide rows into groups. For example, if we have 6 screws, we want to divide them into 2 groups. So we will place 3 smallest screws into first group and 3 biggest screws in the second group. We can also divide them into 3 groups like this here. And for that, in SQL, we will use entile function. This function is using an argument. And if that argument is number 2, in that case, we are dividing our rows into 2 groups. Here we have first 4 rows in the first group and the last 4 rows in the second group. We can also divide our rows into 3 groups. So we have division like this here, but here we have a problem. We have 8 rows, but 3 groups. 8 is not divisible with 3. So what are we doing in that case? Well, first we will create the groups of the same size, but some of the groups at the start of a sequence, will get an extra element. So all of the surplus elements will be given to the groups at the start, and at the end we will spend all of our elements, but we will have 3 groups of the similar size. We will now see how we can use this function in Monet. I will paste here one statement, and this statement will divide our rows into 2 groups. So I will run this, and these are our groups. This is the first group, and this is the second group. We can also divide our rows into 3 groups if we want to. So here is another statement, and now we have 3 groups. This first group has 3 elements, second group has 3 elements, but the last group has only 2 elements. I will clean my screen. The last thing we can do is to give some final conclusions. I will jump to this web page, and I will tell you that when we are using ranking functions, all of the null values will be treated as the same value. With ranking functions, we should always use order by. None of ranking functions is taking an argument except entile function. none of these functions will work with frames, but they will work with partitioning. And if in the two rows we have the same value, then ranking function for those two rows will return the same value. So what I'm meaning is that if here we have 10 and 10, then ranking will return 2 and 2. So it will return the same values because values here are the same. If we go here up, if we have 10 and 10, we would return 7 and 7. So we always return the same value, except for the function row number, which will return different value in each row.